So today what we're looking at is we're going to be measuring the resistance within a series and parallel circuit. So what we're going to be constructing is this diagram down here. We're going to be constructing this using the electronic system. So if we take a look at the electronic system, what we have, we're going to start off with the power pack. So first and foremost, I'm going to set it to 3 volts. It's off at the moment, but that's okay. Now the colours of the wire does not matter. However, what we're going to try and do is we're going to start off with the positive side of the power pack. So there's a positive sign there, and we're going to connect that to a switch. So here's our switch. This is so that we can control when the circuit is on and off. Next, what we're going to have next to the switch is a 10 ohm resistor. If you look back at the circuit diagram, right, we can see that there's only one resistor to begin with, so that's what we're starting off with. So once you have that 10 ohm resistor in, you're going to connect, I would say, you're going to connect this in parallel to the voltmeter. So if we can show that the voltmeter is connected parallel to the resistor, then we can carry on with the rest of the circuit. The ammeter is going to go into the connection here, because remember, an ammeter needs to be in series, and that'll be connected to the ammeter here. Now note that this is the positive side, and I'll explain why that is in a bit. And so the last side, so if this is positive, this is going to be negative, and the negative wire needs to be connected back to the negative terminal of the power pack. And once again, just remember, you do not, the colors of the wire does not matter at all. Right. Okay, so once we've got it all set up, what we're going to do is we're going to switch on the power pack, and we're going to measure the current from the ammeter and the potential difference from the voltmeter. So remember, you've got a switch within the circuit, so you must press the switch in order to make it work. So I made the mistake of forgetting that. So once you've switched everything on, have a go, press it, and record your results. So in this case, my voltmeter reads 2.73 volts. So I'm going to write 2.73 here. The units are there for me already, and I'm going to record the current, which is 0.25 amps. So that's 0.25. Using the formula V equals I times R, we can rearrange that to work out our resistance. So R is going to equal V divided by I. So it's going to be my voltage, which is 2.73, divided by, don't forget your units, divided by 0.25 amps. And here's my calculator. I'm going to do that on my calculator. So it's 2.73 divided by 0.25, which press the SD button if the fraction comes up, so the SD button, and that comes to 10.92, which is what roughly we should expect, because in a series circuit the resistance should be the same. So we've got 10 ohms here, and our calculation shows that it's 10.92, so roughly it is what we expect it to be. Okay, so the next diagram we're looking at is this one here, where we've got 2 resistors. Now the resistors are going to be the same, so we've already got a 10 ohm, we're going to put in another 10 ohm resistor in the series circuit. So if you have a look here, back to the electronic system, we've got our 10 ohm resistor here. I switch our 10 ohm resistor, I'm going to put in another 10 ohm resistor, and it's not difficult to do. This last bit here, you just take that out, put the 10 ohm resistor in here, and then you're going to, that's not in properly, so make sure it is in properly, and then just plug it back in. So now your potential difference is from this resistor here all the way to this one, so that's what our potential difference is going to be reading. Now here we're going to have a different experiment going on. So we should know, just have a guess, have a prediction what the total resistance within the series circuit should be. So remember, we've got a 10 ohm here and a 10 ohm here. So roughly what should be our total resistance by the end? We're going to actually test this. And here's the table showing that. So we're going to have 3 volts, 6 volts and 9 volts. So our independent variable, the thing that we're going to be changing within our experiment, is the potential difference from the power supply. And we're going to record the current from the ammeter, the potential difference from the voltmeter, and using our formula, we're going to calculate the resistance. So let's just do one with you so that you know what you're doing. So remember, there's that switch again, the dreaded switch. Put it on. So my voltmeter is reading 2.85. I'm going to go with. So it will flicker, but just go with what is more stable. So it's 2.85 volts. Make sure you're putting it in the correct places. So that was my voltmeter. That's my voltage. Pressing the switch again. Let's get our ammeter reading, which is 0.12. 0.12 amps. So make sure you're going. Now we can once again, I'm going to call this A. I'm going to show my working out. Resistance is equal to voltage divided by current. So the voltage was 2.85. The current was 0.12. Don't forget your units. So let's get our calculator. It's 2.85 divided by 0.12. Press the SD button if that comes up. And it's 23.75. A bit higher than we expected, but still within the 20 range. And then you're going to do the same for 6 and 9 volts. Okay, so I've now done calculated the resistance for B and C, and what I've shown is that the resistance when I upped the voltage to 6 volts was 21.73, and for 9 volts I recorded the voltage as 8.71 and the current is 0.40. So using this formula here, I calculated my resistance to be 21.78 ohms. Right, so that's what you guys will have different results. Now, ideally, the closer it is to 20, the better the results are. But that's what you're looking for. And remember, why is it 20? Because we've got 10 ohms here and 10 ohms here in series. So the total resistance must be equal to the total within the circuit. In this case, 10 plus 10 is 20.
Can you illustrate?
To finally conclude this portion of the experiment, what we can say is that RT, so the total resistance, is equal to R1, whatever it is, plus R2. Now we looked at two that were the same, 10 ohms and 10 ohms. But what if it was two different ones? What if it was 10 ohms and 120 ohms? What would be the total resistance? That's something for you to think about. Yeah, okay, so for this second experiment, we're going on to parallel circuits. Now, you know it's a parallel circuit because there are more than one loop. So here's your first loop and there's a second loop there. A voltmeter is always placed in parallel, so it's not a parallel circuit because of the voltmeter. It's parallel because there's more than one loop. Now, we're going to construct this using our electronics system again. And I've used some wires here, connecting wires, so that it's easier to visualize. So what I've got, once again, my positive lead, remember color doesn't matter, is connected to my switch. Then I've got the resistor, and then I've got another lead going back. That lead is connected to an ammeter where it's positive, therefore this side is negative, and that's going back to the negative side of the power pack. And then all you're going to need is two more connectors to make your parallel circuit with your resistor connected there. So, and again, the voltmeter is connected parallel to the resistor. But the question is, why are we only going to measure the voltage across one of the resistor? Why not measure it here and here? And the reason is because the potential difference in a parallel circuit is the same throughout the circuit. So let's say, for example, my voltmeter is 5 volts here, it's going to be 5 volts there. If there was another one, it would be 5 volts there, etc., etc. So, with this experiment, it's very similar to the previous one. We're going to start it off at 3 volts. We're going to measure the current and the potential difference to give our resistance. So let me just show you how we're going to do that. Once again, I've set it to 3 volts because that's what it starts off with. So I'm at 9 at the moment. I'm going to go all the way down to 3. Press the switch down to make a complete circuit. And record your voltage, which is in this case 2.36. I'm going to go with. So 2.36. Remember, put it in the correct column. Potential difference, voltmeter. and I'm going to complete the circuit again. The ammeter is reading 0.47 amps, so 0.47 amps. And so again, it's the same equation, so I'm going to call this A again. So A is equal to, well, resistance is equal to voltage divided by current. So the voltage is 2.36 volts divided by 0.47 amps. Back to our good friend the calculator. It's going to be 2.36 divided by 0.47, which equals, press the SD button if you have to, 5.02 ohms. So with that said, you're going to have to do the same with B and C, so 6 volts and 9 volts. Okay, so if you look at our results, we've got 6 volts, and we worked out the resistance using the resistance equals voltage divided by current formula to be 5.06, and we did the same with 9 volts, and it came to 5 ohms. Now, if we think about this, looking at our results, what this is telling us is that the resistance within a parallel circuit is going to be less than the smallest resistance. So if you look here, I had a 10 ohm resistor and a 10 ohm resistor. So my total resistance is going to be less than 10 ohms. Let's look at another scenario. Let's say we had 10 ohms and 5 ohms. The total resistance now is going to be less than the 5 ohms. And that's what you need to know about a parallel circuit and resistors.